talking about myoglobin and hemoglobin, which are two molecules in the body that are very important for the binding of oxygen in the body. So first we've got myoglobin. So myoglobin is very important in oxygen storage. So some features about myoglobin: it has one subunit, and it is useless for oxygen transport, which we will get to when we talk to hemoglobin. But the reason for that is there's no cooperativity because there's only one subunit. So if we move over to hemoglobin, this one is very good for oxygen transport. It's the main carrier of oxygen from the lungs to the tissues. And the reason it's so good is because it has 4 subunits. So there's 2 alpha and 2 beta, which makes it very good for transport because it does have cooperativity. So what is cooperativity? It's just when the subunits will communicate with each other through conformational changes. So when it's no oxygen is bound to the subunits, it's in the hemoglobin is in the T state, so which is the tense state. So in the T state, their bonds between the subunits are very tight, which makes it inflexible and makes the affinity for oxygen and hemoglobin low. So this is when the oxygen pressure is low, like in the tissues. However, when oxygen binds to one subunit, it starts changing from the T state to the R state. So the R state is the relaxed state. So some of those bonds between the subunits begin to break, making the hemoglobin molecule more relaxed and actually making it want to bind more oxygen. So the more oxygen that's bound to hemoglobin, the more it's going to want to bind oxygen. So it's kind of like it just keeps going. So for example, in the T state, when oxygen is low, like in the tissues, it's going to want to give up oxygen because less oxygen is going to be bound, which makes it good for in the tissues. However, in the lungs, where the pressure of oxygen is high and hemoglobin binds oxygen, it's going to want to keep binding more oxygen. Okay, so now that we know the difference between the T state and the R state, we can talk about more effects that make hemoglobin good for transferring oxygen in the body. So one effect is carbon dioxide binding to hemoglobin. So in the tissues, carbon dioxide, which is a byproduct of some cellular respiration, is going to bind to hemoglobin and form carbaminohemoglobin. So this serves 2 effects. So carbon dioxide binding is going to carry carbon dioxide from the tissues to the lungs so that we can get rid of it. And also, when carbon dioxide binds, it actually stabilizes that tense state, the T state in hemoglobin, which will cause more oxygen to be released, which is what we want in the tissues. This is the same for the Bohr effect. So the Bohr effect shows that when there's a low pH, there's a lot of hydrogen ions, like there is in the tissues. It's also going to bind to the hemoglobin, cause that T state to be stabilized and more oxygen to be released. So the Bohr effect causes more oxygen to be released in the tissues because there's a low pH. Finally, we have this little molecule called 2,3-BPG. So 2,3-BPG is going to bind between the beta subunits of hemoglobin and also stabilize the T state, causing more oxygen to be released. So all of these stabilize the T state, causing oxygen to be released into the tissues, which is what we want. One interesting thing about 2,3-BPG though is that in fetal hemoglobin, we actually don't want 2,3-BPG to bind because fetal hemoglobin needs a high affinity for oxygen because it's getting the oxygen from the blood of the mother. So in order to combat this, fetal hemoglobin, instead of having beta subunits, which is where 2,3-BPG binds, will have 2 gamma subunits and 2 alpha subunits. So because it has gamma subunits, it will not bind 2,3-BPG with as high affinity as regular hemoglobin, and so fetal hemoglobin will have a higher affinity for oxygen, which is what it needs. So those are the basic differences between myoglobin and hemoglobin. Just remember, myoglobin, not good for transporting oxygen, no cooperativity, only one subunit. Hemoglobin, very good for oxygen transport because of that cooperativity. Hope this helps.